Hello and welcome back. We are now on the second set of notes here, and today we're going to be talking about operations with vectors. So there's a few basic operations that we can do with vectors. The first one that we're going to talk about is something called scalar multiplication, or multiplying by a scalar. Now, the word scalar basically just means you are scaling the vector. So you're making it longer or shorter. Another word for scaling is dilating. So if you think back to geometry, we can dilate a vector by any sort of constant. So for example, the examples that are on here, we see vector v. Well, if I want to know what 2v is, then it's going to be the vector that goes in the exact same direction, but it's just twice as long. The scalar vector for 1/2 v is the same idea. It goes in the same direction, but it's half the length. And then the last type of scalar that you can talk about is a negative scalar. Now, a -1, what it'll do is it'll create an opposite vector. So it'll take the vector that's given up here, and it'll just make it go in the opposite direction. So that's called multiplying by a scalar. You can make it longer or shorter, or by putting a negative, you can make it go in the opposite direction. The other thing that you can do with vectors is adding and subtracting them. Now, remember, adding and subtracting are the same thing. Subtracting is just adding a negative number. So you can see that right here. This v minus w is the same as saying v plus negative w. So if you know how to add, you know how to subtract. So let's talk about kind of what that looks like here. So if you're going to add two vectors together, here we have a v and a w. Basically, all you're doing is you're lining them up tip to tail. And that's kind of the way that it's described all the time. So you line up vectors tip to tail, and what that will do is it will create a third vector, which is the answer to the adding. So this vector right here is what happens when you add v plus w. You create a new vector, which is the tail of the first one to the tip of the second one. Okay? And like we said, subtracting is the same thing. If I want to add v plus w, we would be going in that direction. But if I want to add v plus negative w, you take v, but then instead of using w going this way, right, it's negative. V plus negative w is v minus w. So it actually goes back, doubles back in the opposite direction and creates this vector right here. So that's adding and subtracting. Okay, so now how do we do this? It's actually pretty simple. So let's talk about kv. So if v is a1, b1, and if I want to multiply by the scalar k, I want to multiply by some constant k, all you have to do is multiply both a and b by k. So it'll be k times a1, comma, k times b1. Okay? For addition, it's just going to be a1 plus a2, comma, b1 plus b2. You just add each individual component. And then for subtraction, a1 minus a2, b1 minus b2. It's that simple. Okay, so you might find this a little bit simple, but it's important to understand what it looks like too. So when you're adding these, the actual operations are very basic, but this is what you're actually doing up here with these vectors. So let's see 2c. Okay, so c is -4, 5. So if I want to multiply that vector by 2, then 2c is going to be 2 times -4, comma, 2 times 5. So 2c is going to equal -8, 10. Now, you may have been able to do that without writing this first step, but it's important that you know where it comes from. So this vector is c, but it's going the same direction as c, but it's twice as long. All right? Number 2 is a plus b. So let's see, a plus b equals. So what that means is I take these 2 points right here and I add the a's, so -6 plus 1, comma, And then I add the b's. 2 plus 7, which is -5, comma, 9. So again, if I took a and b and put them tip to tail, it would create this new vector right here, -5, 9. C minus b. Let's keep going. C minus b equals. So take C and B and start by subtracting the b's, -4 minus 1. Now make sure you're going in the same direction that it is here. C goes first, B goes second, comma, and then 5 minus 7. So this is going to be -5, comma, -2. Again, it's the same as C plus -b. So if you took B and reversed it and put it to the tip of C, this is the new vector that would be created. All right? Now, when they get more complicated like this, you don't have to really think much about it. Just do what it says. A minus 3C. Let's see. So the two that we're using, let me erase, this is a little messy up here. I'm using A and C, right? So start with the A's. I want to do -6 minus 3 times -4. And then I want to take A minus 3C for the second values here. So I want to go 2 minus 3 times 5. So if I can do both of those operations, I'll know what A minus 3C is. So this is -6 plus 12, which is 6. And then I have 2 minus 15, which is -13. So there's number 4. Okay, pretty straightforward. Okay, a couple more to do here. Let's do 1/2 A minus B. So first things first, let's do 1/2 A minus B for the first value. So 1/2 -6 minus 1. Comma, and do it for the second values. 1/2 2 minus 7. Now if you're wondering where these are coming from, just look at the points that are on the previous page. So 1/2 times -6 is -3 minus 1 is -4. This is going to be 1 minus 7, which is -6. All right, and then we just have one more. So 4b plus 5a equals. So do 4b plus 5a. Remember, the order of these is sometimes important, so make sure you write it that way. So let's use the first points in b and a. So 4b is 4 times 1 plus 5a is plus 5 times -6, comma, and then do the same thing with the second points. 4b is 4 times 7 plus 5 times 2. So doing these operations, 4 plus -30 is -26, comma, 28 plus 10 is 38. And there's the answer. So I hope that this made a lot of sense to you. We're going to move on to unit vectors tomorrow. This is it for today, and just make sure you're following along with these so you can do the problem sets when I assign them. Thank you very much.